All right, so now we're going to look at surface area specifically of a cylinder. In order to do this, what we got to do is first off figure out what a cylinder is made out of. So grab a can, any kind of basic, canned vegetables or soup can or something like that, and take a look at it. First thing you're going to notice is right up on top, we've got this and the top and the bottom, which are going to be two circles. Um, so we got two circles there. Now, if you can find a used can, don't do this to cans that haven't been used yet, but if you actually cut off the label of the can, what you'll notice is that you have a nice long rectangle that goes around the can, which is this part right here, is this nice long rectangle that wraps all the way around the can. So in order to get the surface area of a cylinder, first thing we're going to have is we're going to have two circles. And if you remember from earlier, in order to get a circle is radius times pi. The radius squared times pi. Now, one thing to note: how many circles do we have? We have two. They're identical. We could do radius squared pi plus radius squared pi, or we could just do 2 radius squared pi. Okay. Now, when it comes over to our rectangle here, first off, this is going to be the height. That's going to be the same as we have right here on our cylinder. And then, and I'll just put our radiuses right here so we have those as well. Now, what's going to happen with this side right here? Well, what you may have noticed is this, our label that we have wraps all the way around our cylinder. It wraps around our cylinder, meaning that this length right here is actually going to be just as long as the circumference of the circle. Now, circumference of a circle is 2r pi. So what we end up with here is this top level of it is the same length as going all the way around our circle, right? And if you take the piece from a can and kind of curl it back up, you could make a circle out of it, and you'd see around the top there. So all we need to do is take these two, multiply them together. So the area of this right here is going to be 2r pi times height. And we're going to add that to our two circles. So 2r pi times height. So if we wanted to do this as a quick example, it looks like this right here is 1, 2, 3, 4. This is 5 tall and has a radius of 1, 2, 3. And those are the only measures we actually need. So now we're going to go down here and we're going to substitute this in. So we have 2 and our radius is 3. So we put parentheses around that. 3 squared times pi. And we're going to add 2 times 3 times pi times our height, which is 5. Okay? So this ends up, what do we do first? We do our exponents first. This right here is 9. Get our colors back. 9 times 2 times pi plus, this is 6 times pi times 5. Simplify this down. We have 18 pi plus, plus 30 pi. So we add these together, and that'll give us 48 pi. And so 48 pi is going to be the surface area, and we could multiply that times pi. We'd get around 150. Or we could just say this is 48 pi units. And once again, because this is surface area, it's squared, because we're talking about covering it. How many like little squares of wrapping paper it would take to cover it. And that's it for a cylinder. So our formula, 2r squared pi plus 2r pi times height. And that's how you're going to get the volume of any of your cylinders. Now, it's important to note a couple things about cylinders. One of which is that that there's lots of different cylinders. We think of cans, but it's also important to think of things like pipes and tubes, right? Toilet paper of immense value right now is a cylinder, and so we do use a lot of cylinders, and they're pretty common. A coffee cup is a cylinder, so they aren't as rare as we might think. And so this is the formula we're going to use to get surface area to figure out, okay, what does it take to cover a cylinder?